So hello everybody, my name is Joan and I'm here to present Jina AI, a new open source framework for neural search solutions. It's a company, an open source company that I happen to work with, to work for the last 6 months. So this is the outline of the content I want to present. So I want to discuss a little bit before entering into Jina about what is neural search and what is understood by it. Then I want to describe what is Jina, what is the purpose of the company, what is trying to solve. I will go around some of the main concepts that it has and that it plays with, and then I have a little demonstration on the capabilities on a little search system that is implemented with it. I will not do any live coding, it's something pre-built and pre-recorded. So what is search and what is neural search? What is semantic search? So first we need to understand, well, it's a little bit of context. So search is the typical solution that we have all played with or have used. It's about entering some query and getting back some information. The traditional system will use any kind of word, any string, any phrase, and will do some matching based on common words, common sentences, common letters, whatever, depending on the logic behind it, and it will get back information. This is the typical solution, but for the last years, the way we look for information in internet or in databases, it has shifted. So right now, the amount of information out there is so big, it's so varied, it's so diverse, it comes in different shapes and forms. So right now, it's easy to find images out there in the internet that we are looking through text. In this case, it's typical that text images come with some metadata tags or whatever. But we can we could look for them based on content. And that is more or less where neural search comes. Neural search, semantic search, AI search, it's a lot of words that what they mean is that they are based on embeddings. So this is the meme, embeddings everywhere. So the main idea is that instead of looking for matching words or matching sentences, we are looking for vectors in an embedding space. So basically, with neural search, you can look for any content that you are able to project into a high dimensional space. And that is where the neural world comes in. It's normally these embeddings are learned through some neural networks, and they are extracting features from the content, the documents, the images, the text, the videos, the audio. They are extracting a set of features that are projected into an embedding space, and where we expect that similar content, similar images, similar words, similar videos, they are close to each other, and we are also expecting that those that are really different to each other, they will be far apart. That is a simple concept that has a lot of power, and it is gaining as traction as the AI models, the neural network and research is evolving. All these models are better at extracting meaningful content, and therefore the neural search systems are working much better every time. So the basic thing is that before when we think about traditional search systems, we are we tend to think about words, about strings, about text. You are inputting some text and you are getting some text back. But with this embedding space-based search, we can have a shift of paradigm. So we can look for text, obviously. We know that there are a lot of models that extract meaningful content from text, not only words, but concepts. You can relate concepts like some verbs that are similar, some gender and person like king and queen. We all know the word embedding differences, and so we can look for images, we can look for audio, we can look for video. But not only that, we could even, I mean, you can imagine, we could even do what we call cross and multimodality search. For instance, we can look for images through text when or we can look even for instance in this example we can look for an image with some text and combine the embeddings to do some search that extracts meaning from both the image and some description text. And from here, it comes your imagination and what your models are able to extract meaning from. So for instance, here it's an example. What is an embedding space? What we can see is a projection into a two-dimensional space of an embedding space from Fashion MNIST dataset. And what is impressive and here is that here not even a single embedding has been learned. Only by projecting the pixel intensity values, we can already see some patterns that some jackets are close to each other, some shoes are close to each other. Imagine what we could do with much more training. All this separation would be more clear, and we could be better at searching for similar piece of fashion clothes with given images as input. So I think that it is clear now what is the basics of a neural search system. So let's discuss more or less I think these are the pros and cons of symbolic search, traditional search based on word matching, sentence matching, and semantic or neural search. So symbolic search, that it's what I call inverted index based. It's efficient at query time. It's really optimized to find matching words and matching keys in their system. It is quite straightforward to implement, and and what I think is more important, it is very easy to interpret the results. It's very easy to understand why you get the output that you are getting. However, one of the big cons is that the knowledge is hard coded. It's not flexible. There is no context in the information. If you are just giving a synonym of a word, it's hard for it to get. Then the cost of maintenance is very big. It's hard to get it right. It's hard to adapt to different languages and so on. And it's limited mostly to NLP. However, in semantic or neural search, the good thing is that it's content based, it's based on feature. There is no hardcore knowledge that you need to have previously. It's agnostic to data types. You can search for whatever. And one big thing is that it aligns with the research and with the advancement that we are seeing in the AI world. So it has a lot of growth potential. Imagine what is being done now, it's likely that they will perform even better in the future. However, it also has its cons. It requires trained models with problems that it involves. It is less interpretable than symbolic search. It's not so clear sometimes why do you get the results that you are getting, but this is something that the AI community is working on to understand better the models and to work with that. So let's hope that we can cross that as the cons. And then it's harder to add some business rules, for instance, because sometimes there are business rules that are easy to implement in symbolic search that you don't want a specific content to be output that is not so straightforward to implement here. So once I presented the neural search, what it is, I would like to present Jina. So Jina is an open source framework for neural search. It is an open source framework that allows you to design and deploy your neural search solution, whatever it is. And the vision around Jina is to capture all the design patterns that are emerging from the industry and the research and make them ready for deployment for you. So Jina is born to be universal in the sense that we discussed before. We need to have support for multiple data types. It's totally data agnostic. Whatever data you want to search for, it is available or it is enabled to do. It's with less effort you will be able to do it. It plans to cover any multi-cross modality search pattern. So you would be able to search for images with text, for text with images, anything you can imagine. It's born to live in the cloud. It's born to be distributed because one of the main challenges when building these systems is to have them scaled and perform. One important thing is extensible. So the point is, it is very hard to think that a single solution or a single framework will be able to cover out of the box any custom any custom demand from any user. So the amount of customization that we need to cover, it would be unfeasible. So in Jina, a lot of thought has been put into this and into have a good developer experience to have kind of a hub like Docker Hub or like TensorFlow Hub that it's easy to extend and so that you can put your own custom implementations in a very easy way into a Jina flow. And it's open source, so it's born open source and is built to serve and to follow the community and to live from the community's feedback. So the main components in Jina I will explain in more detail, but so for to know, there are four main concepts that we need to understand. So the first concept or class or family member that we can think of is the flow. The flow is the main component from that the user will interact with and the user needs to define. And it defines the search application structure. It defines how the data will flow and will go, which components will go. It needs to be encoded, it needs then to be indexed, it needs to be filtered, whatever. Then there is the concept of pod. A pod is the microservice unit, is the distributable unit that Jina has, and it provides like the runtime support for the actual work. It supports the distribution, sharding, replication, parallelization, etc. Then is the executor. The executor is the component in Jina that owns the actual logic, that owns the algorithmic power of Jina. It will do crafting of the documents. It will, for instance, read an image from a file. It will normalize an image. It will cut text into chunks by punctuation marks. Then will be encoders. We could encode an image into a vector. We could text. We support transformers, for instance. Indexers, we have vector indexers, approximate near neighbors, or rankings. This is what we thought that captures most of the 99% of the design patterns around neural search. And if we are if we find new patterns that need to be supported, this family is to be extended. And these executors are the ones that are extendable by the hub that I was mentioning before. So these have been designed to provide an interface that whoever can implement on their own and have their own custom logic encapsulated and distributed via Docker containers. And then there is the document. Document is the primitive data type of Jina. Is the array of NumPy, the tensor of TensorFlow. It is a recursive data structure because it can be chunked. This is important because search in neural search, one important thing to have is that the comparison between embeddings need to happen at the semantic unit that is meaningful. For instance, if a document comes, a very long document, maybe you cannot compare a whole document with a whole document. You need to chunk these documents into paragraphs or into smaller sentences and compare sentence to sentence. And that is where the semantic unit makes sense to be compared. So Jina has designed this document as a recursive data structure so that you can chunk as many times as possible and it can cover any flow, any requirement that you may have in terms of cutting or chunking your documents. So this is a flow. So this is a flow. In this case, we have a gateway. A gateway is like the entry point where the client will connect and will send the documents. Then in this case, yes, I forgot to say, we are designing a search system where we will input lyrics from songs. We will index them and then we will query them by via a sentence. Imagine that, I don't know, it happened to everybody. You don't know the title of a song, but you know some sentence in the lyrics. So you would like to look for it. So let's see how we would do this. So we would have a gateway that it is a main component in Jina. It will always be there. Is the like the entry point. Then what will happen is the lyric. Well, no, that comes later. So here is on the left, you can see how we define a flow. It's defined via YAML file, via a YAML file, very easy to define. Then you define the pods that live there with YAML files, and you can see here an image and an example of a pod YAML file that describes which executor is being used. Yeah. So you can define via YAML Pine, via Python, or there is even another component of Jina that is the dashboard that lets you that design these things. So let's see here. So in the gateway it comes and the full lyric comes here. On one side on the left, the full lyric will be indexed in the document indexer for later retrieval with nothing else. Just will store the ID of the song and the full lyrics. But on the other side, this goes to the segmenter. And the segmenter segments the full lyric into a title, sentence, and sentence. And the encoder will will encode all of these chunks into their embedding space. And it will go to the chunk indexer and store them in a numpy. It's a kind of a numpy array. You could load it to an annoy indexer, whatever. It's for nearest neighbor search. And at this point, when you query, you would query with any sentence, and there will be a comparison between the sentence and all these subparagraphs. And then there will be a ranker that will re-rank all these songs, and you will extract the best matching song. Which brings me to the point of the demo. Now we will see a demo of what I just explained. It's a pre-recorded demo of this lyric search working. It's a pretty good, nice video. I don't know if you guys listen to the music, but here you can see how we have indexed here the lyrics, and you can select an input and select how you chunk, and you can see how the matches are computed. You can select the distances that you want to filter or not. Just for your information, the front end part is built just for the demo, but it's not part of Gina Core at all. And these colors is not part of our main thing. A little bit of promotion. Sorry. And then, so for summary, so I would like to put these take-home messages. So neural search is more, it goes along, or it's a paradigm shift on how we see search and how we implement and how we deal with search. Gina is one open source solution that supports all the neural search pipelines. So if you have any problem that you think that it can be solved with neural search, just go give it a try. It's easy to use and easy to extend and thought to be extended easily with custom models and executors. And that's everything from me. So thank you very much. If you want to learn more, just give us a star, follow us on the social networks, or join our community Slack channel. Thank you very much for your attention.